to the February 2024 Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov, and I'll be your host for this evening as usual. On a personal note, it occurred to me that tonight, marks exactly 23 years for me organizing and hosting these meetings. In fact, it was February 7th, 2001, when I hosted my first meeting here at the Ontario Science Centre for the RASC. Now, thank you. It's not a round number or anything, it just happened to be also on February the 7th, so that stuck out. Now, I was going to say that some of these volunteer jobs should really not be for a lifetime. So if you're willing to help out, take over, let me know. I'm all ears. Talk to me. But nonetheless, I'll be happy to continue organizing and hosting the meetings until somebody else wants to help out. So for our online viewers, we are here at the Science Centre, as usual, in front of a live audience of at least 25 people tonight, so a little bit more than usual. Nice to see. And if you're not here, we hope to see you in person next time. For those of you who definitely cannot make it in person because you're too far away, rest assured that the broadcasts will continue to be on YouTube. And that's, of course, possible due to our great AV team, tech team, comprised of Andrew Reed and Wardley Grow and a few others who I don't see here tonight. Oh, and Betty as well, Betty Reed as well. So as you know, I'm always searching for presentations. The March meeting is full, but the April meeting is wide open. Now, the April meeting occurs on the 3rd, which is the first Wednesday of each month, as usual. And it's also a few days before the total solar eclipse. So we're not going to have any solar eclipse presentations at the April 3rd meeting. Of course, we'll have those for the May meeting. And if you're thinking about presenting to us, please get in touch with me. I expect a lot of people will volunteer, and we may have to scatter the presentations in over 2 or 3 meetings into the future. We've had to do that in the past with other popular events. We couldn't fit everybody in the same night. It also gets very repetitive, so it's better to spread them out a little bit. All right, so for tonight, we have 3 presentations as usual. We have Claudio Oriani. He'll present the sky this month. Followed by Andrea Girones, coming to us through video from Ottawa, and she'll present on sunspots and solar storms, observing and imaging. And then we'll have Ron Macnaughton. He's here in person, and he'll talk to us about how ancients predicted eclipses. And Tom Luton will close the meeting with announcements as usual, and we should be done by about 9:30. If you're watching us online and have a question, please enter it in the YouTube chat box, and somebody in our AV team will ask the question on your behalf. If you have a question here in the meeting room, wait for me to come to you with the microphone so that the folks online can also hear your question. And show of hands, do we have anyone here for the first time? Member or not, it doesn't matter. Very good. Welcome. Good to see you. And I think we're just about ready to get started. Before we begin the presentations, I'd like to call on our president, Tom Luton, to do some award presentations. Come on up, Tom.
Thank you, Paul. So one of the joys of being president is handing out awards. So the province of Ontario has a volunteer service award, and this is an award given out to members of organizations who have contributed to their club, their society. They've made a strong, lasting impact over several years. We've got a number of these. Now, not everyone who was given an award could make it tonight, but still, they all are worthy of recognition. So to start off, a quick round of applause to the 2 winners of our Youth Volunteer Service Award, Arushi Nath and Artash Nath. So round of applause for them, please. Next up are our winners of the 5 Years Service Award. Adrian Aberdeen, who could not make it tonight. However, the next two people are here. You folks in the AV department recall I said there'd be a surprise. Surprise! Andrew, Betty, if I can borrow you for a moment. Folks on YouTube, I apologize if the reception gets a little wonky. So our 10-year award is given to Genevieve Seabrook, who unfortunately cannot be here tonight. And last but certainly not least, our 25-year service award is to Scott Masterton, who is here tonight. Congratulations. All right, Paul, back to you.
All right, so just a quick intro. Claudio Oriani to present the sky this month. Come on up.
Hello, everyone. It's a full room here, so glad you're here and we're online. My name is Claudio Oriani. Probably you already know me. I started being part of RASC Toronto Center in 2017 when my daughter was born, but I started astronomy when I was 12 when I got my first telescope from my dad. So tonight I will talk about the sky from today, February 7th to March 6th. And there are few things happening, so I will start right now. Oops, the mouse is off. Okay. There's a problem with the mouse. Okay. A glimpse. Of course, there is already the first typo here, as you noted. Jupiter, Uranus are still visible the first part of the night, but that's pretty much all about the planets at night because all the other planets are too close to the sun. So Saturn is very low and very dim. Mercury is in conjunction with the sun on February 28. But we have Venus still not too high in the sky in the morning, and next month will be definitely much better for Mercury. We have two bright comets, and one comet is not too bright, but is going to have a close encounter with the bright star, so keep an eye on that. The end of February is the best time of the year to see the zodiacal light after even in twilight, for a couple of weeks, and a couple of suggestions for deep sky objects for February, a deep sky challenge, and plus some stuff about the International Space Station passages and transit, plus, wait a sec, I will let you know. So let's start with how many hours of dark sky we have. Of course, we are getting closer to springtime. So if you go on timeandday.com and see for the current month, so you see that we have 7, that's what we have. We have 10 hours and 37 minutes of imaging time today, but in March, when the next meeting is, we have 9 hours, 21 minutes of imaging time. That means that there is more daylight. But for, who's going out for astrophotography, we are not that happy because we lose like 1 hour, 60 minutes of imaging time. but the weather is going to be cool, less cold. So let's start with what we can see in the sky tonight. It's 7:30. So if you go west, you see that Orion is up, is on the southern sky, higher in the sky, and we are losing Pegasus, Andromeda. They are getting lower and lower. But if you go southeast to northeast, you see that Gemini, and you can start looking at Leo and other, spring constellation. So soon is going to be galaxy season. So take the dust off your scope. And if you look at northeast, you see Cepheus is still quite a good target, and more and more stuff happening when you go up 10 o'clock p.m. You see that Orion is setting. There is Jupiter to the bottom right, so you can still see Jupiter quite high in the sky at the beginning of the night, but then it's getting worse. So you have a few weeks still to look at Jupiter. And then the spring constellation getting higher. So Leo is very high at 10 o'clock. Midnight, it will be perfect target, almost at the meridian. And Perseus is still low to the horizon, so there is a lot of atmospheric dispersion. The sun, maybe you have noticed that the sun in the last few months is very active because it's getting to its maximum for this 11-year activity. It seems like the maximum will be, it was supposed to be in 2025, but it seems like it will be a little bit earlier. So it's a lot of sunspots. There is one that's pointing straight to us. So if there is an X emission, we are going to have a nice time for northern lights. Finger crossed for that. You can have a look on spaceweather.com or the NOAA.gov website to see if there is any alert for aurora. There's also an app. I use it for my smartphone, my aurora forecast. You can have notification of something happening if the threshold is reached. The moon. So we have the perigee on February 10, and the apogee is on the February 25th. That is happened to be around the full moon. We are always talking, we'll see on the, the highlights, there is a super moon. This time we have a mini moon, I don't know how to call it. It's smaller than usual. The smallest full moon in 2024, on February 24th. And the traditional name, full snow moon, I don't think there is a reason to explain why. On Friday, February 9th, so in 2 days, we have the new moon. So it's best time of the month to do stargazing if the weather cooperates. We have a few events happening. The moon is meeting a lot of planets and bright stars. So the first one is very difficult to spot because on February 10th, there will be Moon and Saturn in conjunction. The red circle you see around in the image is just a projection of what a 135 millimeter tele lens can capture. So it's a good target to try in a couple of days. But the moon will be very low to the horizon, no more than 6 degrees. So it's very hard to spot. Let me know if you can take it. On the 16th, there is another good opportunity. The moon and the Pleiades will share the same field of view. So I know that there is some astrophotographer using his camera very often here and maybe online. So maybe you can try this one as well. And this is around 7 o'clock p.m. The moon will also meet Pollux Beta Geminorum on February 20, and they're very close together again. While if you go on February 23rd, the moon will meet Regulus in Leo, and they're very close again. Then the moon is Spica in Virgo on the 28th, also very close. It's a bit later at night. And then the clue we are just missing for some half degree. The moon meets Antares in Scorpio, but here there is no occultation, just for a couple of degrees, I believe. In some areas of North America, there will be occultation, but we have more chances to see occultation than Antares from the moon. So keep this date, say this date, March 3rd. The moon and Antares are very close together. That's what I can see from a stellarium, just a close call, but they don't overlap. Sorry about that. Next time. Mercury, as I said, this month we technically have some chances to see very low on the eastern horizon in the first half of February, but on February 15, its elongation will be 10 degrees. Its magnitude minus 0.7. So technically you can try to spot Mercury, but then superior conjunction on February 28. March will be much better month, and in the second half, there was the best opportunity to see Mercury in the evening sky for the northern hemisphere. Venus is the brightest object in the morning sky, of course. On February 7, today, the magnitude is minus 3.93, so you can't miss Venus, but it's also very low in the morning sky, only 6 degrees above the horizon. It's close to Mars, and I will show you soon, on February 22nd, Mars and Venus will be very close, less than 1 degree apart. Mars is unfortunately 100 times fainter, and since there is the light of the twilight, it's very hard to spot. Maybe with the camera you can. This was this morning. You can see there were 3 objects: Venus, Mars to the bottom left, and the moon to the bottom right. Venus is the higher in the sky, was 6 degrees. So the moon and Mars were like 2 degrees and 1 degree. And then on February 22nd, this is what I noticed, that is Mars and Venus are less than 1 degree apart, as I said, but Mars is plus 1.27 magnitude. And this is 6 o'clock in the morning, just a few minutes before sunrise. Mars is getting slowly higher in the sky. In March, the separation will increase, but the size is still very, very slow, only 4 arc seconds. It's getting better because at the beginning of next year there will be a new opposition. Jupiter is still very prominent in the evening sky. It's at after midnight today. If you have a telescope, try to observe in a twilight because you have a higher contrast against the blue sky. And there are lots of events like this one I captured. So there was the Great Red Spot, and the shadow, I believe, was Europa, was passing in front of Jupiter a few months ago. Then again, Jupiter and the moon will meet for Valentine's Day, I guess. They're 3 degrees apart. Again, this is around 8, it's 10 o'clock. That Saturn, that is very low in the sky, so you have a few days to capture Saturn before is disappearing because in conjunction with the Sun on February 28. So say goodbye to Saturn and wait for next month to go back in the morning sky. Uranus is still a good target because it's not far from Jupiter. It's at 10 degrees apart. It's still well positioned in the sky. And the moon will pass 3 degrees north of Uranus on the day after Valentine's Day. Neptune, forget about it because it's very, very low and very, very dim. So this picture I took was August 13, 2022 with my Celestron 8 SST, a dedicated planetary camera, and 2.5 power made. It's nice I can spot Triton here. but is 7.8 magnitude, so forget about it because it's very low and is in the twilight. So say goodbye to Neptune as well. But on the other hand, the end of February is the best time of the year for the zodiacal light after sunset. First, you need a dark sky. Second, don't mess with the Milky Way. Basically, the zodiacal light is why is March the best time of the year? Because the ecliptic has the steepest angle. And you can see this interplanetary dust that is light by the sun. Into discovery, I believe from Juno space mission, while it was reaching Jupiter, seems that the material of this interstellar dust is coming from Mars. So the interaction between the solar wind and Mars leaves like this dust in the sky, and we can admire after sunset, the end of February, between February 26 and March 8, when the moon will be back. If you are going on a dark sky, try after sunset, you may capture this beautiful event. Comets and asteroids. We have a few events here. So the asteroid Juno will be at opposition on March 3rd, and its magnitude will be 8.72. We have a few comets. A few of them are very bright. So there is the comet 12P Pons-Brooks that will reach 4.5 magnitude if everything is going according to plans in spring. So it's a good target to look at. But as I think David Lewis say, never trust comet because they have a tail and they do whatever they want like the cat. So never trust a comet. Maybe I can tell really slowly. Remember that name. I don't know that accent is correct. Chuchin-san. So there is one comet here. Is nothing to do with the other Chuchin-san that could become very bright in October 2024, but very, very bright. Finger crossed for that one. In the meanwhile, so that's Juno in Leo on March 3rd at the position. You can try to capture because it's 8.72 magnitude, so should be quite easy target to spot with the binocular or with a small telescope. This is the first comet, Chuchin-chan 1. Is a periodic comet. When you see the P in the name of the comet, it's a 62 periodic comet. And I think that the name Chuchin is the Chinese observatory that is on the Purple Mountain. Eastern. This one, it's very interesting. I noticed a few days ago, the comet per se is not particularly bright, but tomorrow will be less than 1 degree apart from Aldebaran in Taurus. So if you have a camera, if you have a binocular, if you have a telescope, try to capture between tomorrow and February 10th. This comet can be a surprise. Although its magnitude is only around 10.7, so it's not too bright. Maybe if you never had the chance to see a comet, this can be a good one. And on February 2nd, there is another encounter, the comet 12P Pons-Brooks meets 1 Lacerta, that it's a quite bright star because its magnitude is 4.15. This is imagined from Stellarium at around 8 p.m. While the comet the magnitude will be around magnitude 8. Deep sky. I mean, we all have preferences. My preference, because I'm lazy, I got a message, can you get, why don't we go, guys, on Clay Major Forest? And I was already setting up my narrow band. So no way, I took a few images a couple of nights ago after 60 days of cloud. So I took the Rosette Nebula, I took the Horsehead Nebula. Great Orion Nebula, of course, is a very good, is a prime time. So you can see 8 o'clock, 7 o'clock p.m. is there, south horizon. And the Crab Nebula, if you have a bigger telescope, I would say, in Taurus. And if you are a fan of open cluster, there's plenty of them. Pleiades, M45 in Taurus. There is a sequence of Messier objects, M35 in Gemini, M36, 36, 37, 38 in Auriga, and M41 in Orion. You have plenty of them. And then, that's tricky one. So a couple of nights ago, I was out and I said, what I can capture. I was just checking the best object and I said, oh, I never tried this one. This is very dim because its magnitude is 11.05. It was discovered in 1795 and is basically the same of the Bubble Nebula kind of object because it's a Wolf-Rayet star that is lighting and is a pre-supernova stage. So the gas is very bright and blue. And this is only 50 minutes total integration time. It's a hard target because it's very low. I don't think it's getting never higher than 20 degrees to the horizon, but it's worthwhile to try it. It's NGC 2359, Taurus helmet, in Canis Major, not far from Sirius. Visiting of the International Space Station, we have a few of them. The magnitude when is minus 3.5. This usually means that is going very high in the sky. For the last few days of this month, it will be visible in the morning sky before sunrise. And there are a few of them. You can go on the website Heavens Above, set up your coordinates, latitude, longitude, and check where is the next one. There are a few of them, as I say. And specifically, this is one of the best. You see, if you click, you can see the map when the International Space Station is brightest, when it's exiting the shadow of our planet, and where it's going. And if you go on the Transit Finder website here, you can also try to see, of course, now the YouTube video is not working, but it's okay. You can try to see if there is a passage of a transit of International Space Station or Tiangong, or even the Hubble Space Telescope in front of the moon of the sun. So in the image, you can see the moon, and the bright spot to the bottom right is basically the International Space Station was transiting. It was a few years ago. I think it's stuck somewhere here. Technical difficulties. Oops. Yeah, I think the presentation is stuck on the video, trying to get the... Yeah, we have a few events in terms of space mission. I can't get to the page because it seems like the computer is not responding. It's a technical, yeah, it just stuck. So probably will die soon. Okay, it's not going 42. Let me try. No, it's gone. Let me try this one. Okay, I won. Space exploration. Sorry about that. There will be more Starlink's launches, so it will destroy your deep sky imaging, and not only. And today there was a launch of Falcon 9. Also on February 10, another Falcon 9, more Starlinks. Sorry about that. If you go on the website spaceflightnow.com, launch schedule, you will see all the launches, and it's pretty much here. And there should be a February 2nd Falcon 9, a new crew that is reaching the International Space Station. This launch was already delayed. I don't know if this is the latest date. We will see. And again, at the end of February, another Falcon 9. They can tell you what is that about. Secret. And that's all about it. Questions?
And it's for Claudio. Anyone in the room? No questions in the room. How about online? No questions. Okay, well then I'll throw in a comment. You spoke about Comet Kushida.
Yes.
I was out on Saturday night. I looked for it. It was conveniently placed from my backyard. Visually with a 10-inch telescope from Markham, absolutely not a chance. I was hoping I could barely see it, but nothing. So I said, okay, let me try an image. So I used an 80mm refractor with a monochrome camera, 1 minute exposure. The comet barely shows up, which was surprising because typically 10th magnitude, a minute exposure is visible very easily. So I don't think the comet is performing as it should at magnitude 10.1.
Yeah, as I would say, comets are like the cat. They have a tail, do whatever they want.
Exactly. Yes, we have a question or comment from Eric.
Thanks, Paul. Claudio, so we got a question on our RASC Facebook group recently about the green comet. And I think we worked out that this was actually something that happened this week last year. It was a comet called Comet ZTF.
Yes.
Did you see that?
Yes, I saw that and also imaged that.
I actually found I took an image of it as well
Yeah.
about a year ago next week.
Yeah, exactly. It was a very well-performing comet, by the way. Yeah, I believe on Instagram somewhere there should be some of the image I took last year. And that's pretty much it.
Okay, if there are no more questions in the room or online, we'll say thank you. Oh.
Hi, first-time caller, long-time listener. No, but actually, I know nothing about astronomy, but I'm so happy to be here. This is wonderful, and you said something that made me want to ask a question. You can't see something with your eyes, so you catch it with a long image, and you're maybe able to pick up light for the sky looks totally dark, but if you take a picture, you can see something. Is this what I got? Awesome. Thank you so much. That's all.
Basically, the human eye is not sensitive enough to pick up faint light. That's it. The camera is much more sensitive. Okay, well, thanks again, Claudio, for presenting to us. Well done. Right, so we'll move to our next speaker, who is coming through live video link from Ottawa, Andrea Girones. Andrea, are you there?
I am. Hi. Can you hear me?
Room we can. Now we need to see you. There we go. We see you.
No control over any of this, so.
Go ahead.
Well, thank you very much for inviting me. I'm very happy to be here to talk about solar observing and imaging. It's something that I really enjoy. And as mentioned already, we are approaching solar maximum, which is the peak of the 11-year solar cycle. And that means there's so much activity and it's really exciting time to look at the sun. Who am I to come and talk to you about this? I'm just a hobbyist. My day job is a lawyer. I do live in rural Ottawa, so I have a bit of a dark backyard. I do nighttime astronomy, of course, but I started doing solar astronomy a couple of years ago, and it's really nice. You get good night's sleeps. It's warm and sunny. You need sunscreen. So I've really enjoyed solar imaging. I've published some of my images with the Royal Astronomical Society. Basically, I want to tell you all a bit about solar imaging so that you can participate in this really big year for the sun. First, the eclipse, and also solar maximum. Oop, wrong way. Okay, very briefly, this is a diagram that helps illustrate the concept of solar maximum. Essentially, the image on the left describes the magnetic field of the sun on the sun when it's in solar minimum. Everything is very straight and organized and very quiet, and there aren't many sunspots. However, over time, because the sun has differential rotation, it's faster around the equator, these magnetic lines start to get tangled. They get tangled, they get really messed up, they start interacting, and they get very angry. And eventually you'll see little spots of magnetic field bursting through the photosphere of the sun. This is sort of a close-up of what a sunspot is. It is, you can see the magnetic field loop is popping out through the surface of the sun, which was called the photosphere. And because this plasma cannot cross the magnetic field lines, you develop these areas of sort of trapped gas, cool sunspots, which are dark. So the darkness actually means these are cool areas. And the longer this solar maximum cycle goes on, the more complex and more active the sun becomes. The first and easiest way to do solar observing is to use what's called a white light solar filter. And I'm assuming many of the people in this audience have a telescope. And so one of that they use at night, bring that telescope out during the day and put a front mounted white light filter. And you'll be able to see details on the sun's photosphere, such as sunspots. You'll also be able to see something called granulation. So it's like the granules on the surface of the sun, particularly as it gets close to the edge of the sun, they become more distinct, they're whiter, they're called faculae. Many people who do both observing and imaging often use something called a green continuum filter, and you can use it visually and you can use it for imaging. When you show people it visually, they do wonder why the sun is green. All right, so these are my solar filters, and as you can see, I wouldn't win any prizes from kindergarten teachers. I do my cutting. It's not very professional. However, all I do is I make a holder for my film. And the film that I buy, I bought a roll of it. It's Bader number 5 Astro Solar film. This film will be safe for both visual and photographic solar observing through a telescope. Don't hold it up to your eye, but you can put it on the front of your telescope. And you'll see here as well, I have those little red circles are planetary cameras. Anybody in your group who takes images of planets will be familiar with planetary imaging. We tend to take videos, and then we use software to stack the individual frames from a video. You do the exact same thing with solar observing. You might also notice there's a box in one of the pictures. When you do solar observing, you need to shield your computer from the sun. You need to, wear sunscreen, sun hats. You got to take care of so you don't get burnt. This is just an example of what we need to do, which is take a video. And this was a sunspot grouping. It was one of the biggest ones that we saw as of last summer. And we take a video, and eventually we will run this video through a software program, and that's going to stack the individual images. And so what would happen, I couldn't use this film because of the cloud, but on a clear day, you can get an image like this one. And pretty much anybody who has a planetary camera white light filter can get this kind of imagery of the sun. And you can see along the edge there is granulation, and sunspots themselves have a dark center, and they have a lighter, the center is the umbra, and then they have a lighter penumbra. One of the things that can get pretty complicated these days when you're looking at the sun is trying to figure out, well, what is that sunspot group and which way is north? You'll see actually that my image is a little slanted because normally the sunspots do go across from east to west in a very straight line. So mine are on an angle. What I tend to do when I do my solar imaging is I have my phone and I use the Space Weather Live app, and that was also referred to by your previous speaker. And it has a section just on the sun. It talks about solar flares, CME launches, and it has a sunspot map. And I do a screenshot on my phone and I keep track of it because literally the sunspots change every day. And that's why we love the sun. It's always changing, it's always moving. I also take a screenshot of a picture of the sun in H alpha, and that's a different kind of telescope, and I'll talk more about that in a moment. But again, it's the Gong network, and they have H alpha telescopes looking at the sun from all around the world all the time. So again, I take a snapshot because I want to be able to go back and match up the features of the sun to the sunspot, and then sometimes I actually do a sketch for my journal. And honestly, it's gotten so busy on the sun, you have to keep track because it's really hard. Oh yes, I wanted to talk about this. I showed you before white light filters on a telescope. You can use them for your camera. In fact, most of my eclipse photography is done with this kind of solar filter. Again, you know, kindergarten skill level here. But you just stick it on your DSLR, your mirrorless camera. For the total eclipse that's coming, this is what I'm using. What you do have to remember is you got to take that filter off during totality. Then you got to put it back on. So remember to take it off, remember to put it back on. So I have it's a static tripod, and that's what I use to take this image of the solar eclipse in June near Ottawa. Essentially, because when you put that filter on, you will not be able to see any of the landscape. You have to get there before the eclipse, before the sun has even risen, take your foreground shots. Then you're going to stick the filter on and you're going to catch your eclipse, sun and moon as they go by. And you'll go back home in Photoshop and you will put them together. And this is similar to what I did when I was in Albuquerque for the annular eclipse. We had to get there really early. I had to take the foreground before the sun rose above that mountain. I knew it was coming out of the mountain, so I knew how to frame everything. But once the sun has come over the mountain, you need to put that filter on to protect your camera sensor because you will melt your camera sensor. Okay, that's white light solar observing and imaging. You can do a lot of really interesting things really inexpensively. H alpha is like a step up in the telescope front. There are generally out there are what they call dedicated H alpha telescopes, and that's all they do. And then there's things that are called like eyepiece filters, such as the quark chromosphere, which is a filter that goes on your regular telescope where the eyepiece belongs. And I have both, so I'll tell you about both. I began my journey with solar with this teeny little scope, and I don't think people really appreciate how little it is. Here it is. It's tiny. It's the smallest, cutest little scope. And it comes with a dovetail, and it comes with a little finder. You can use it for visual. You can just stick an eyepiece in here. It's really lovely for visual. And you can thread on your planetary camera, and you can take pictures with it as well. I did almost a whole year of just imaging with this telescope setup. You can see it's light enough to go on a Star Adventurer, and a Star Adventurer has a solar tracking speed, so it's perfect. This is the kind of images that I was able to get with this little tiny scope. I do most of my solar imaging with a monochrome camera. So the monochrome camera is more sensitive. It's very high contrast. And then you can add false color. And I'll explain how you do that a little later on. But most people who do solar imaging, I've tried with my color camera, and it's really hard to do it with a monochrome camera. The other thing you'll note here is that my images, I tend to process a lot of them inverted. For some reason, because the chromosphere is what we're observing in H-alpha, is a little higher above the photosphere. When you invert it, everything just sort of pops a little more. So you'll see in white, those are filaments, those are solar storms, and the dark areas are actually really bright areas, and sunspots are the white spots you see there. So it can be a little confusing for people. Some people don't like it when you invert your image, and people online, they get upset and they want you to do it natural. So prepare yourself. So after a year of doing imagery with the Lund 40, I decided I wanted to go deeper. I wanted to get really, really, really close up. And I got really, really close up with a quark. And the quark comes in two modes, a chromosphere version, and the chromosphere allows you to see really excellent surface detail, and a prominence version that's really good for the prominences which you see along the edge. Now, I can still see prominences with a chromosphere filter, which is why a lot of people like buying the chromosphere version, because you can use it for prominences and the surface. I use just a regular, simple doublet refractor. It's 102 millimeters. That is the biggest size telescope you can use without having a front-mounted filter, rejection filter. I'm going to explain a bit more about the imaging train, but anyway, this is the setup that gets me much deeper, and I'm going to explain a little bit more about it, how I set it up. This is the imaging train. So the quark part is actually, I don't know, can you see hopefully you can see my mouse. The black and white piece in the middle is the actual quark filter. There is a little dial, and you can sort of play with the wavelengths, and you do have to plug it in. It takes power. You will need some adapters. You'll need a UV IR cut filter on the front within the imaging train. This is all at the eyepiece side, because the IR cut filter is actually an energy rejection filter. For small scopes, you can put it there. For a larger scope, you will need to mount it on the front. So most people just do 102 millimeter refractor with a quark. One of the things people don't realize when you get a quark is it has a built-in 4 times Barlow. So it's super zoomed in. So a lot of people use a reducer. So they have a Barlow to zoom in and a reducer to widen the field. And you'll see why that's important shortly. And then I've put in a tilt adapter. I used the ADC, which is something that planetary imagers know about. It's an atmospheric dispersion corrector. A lot of people have one of those for planetary. I use it sometimes to tilt the sensor. If I ever there's an artifact you can get known as Newton's rings. And a little tilting sometimes gets rid of that. So the quark, if you get the quark, you have to be also prepared to buy a whole bunch of little accessories. So this is my quark setup in the backyard with 2 different ways. When I first bought it, I just stuck the eyepiece into the diagonal, and that works totally fine. And lots of people, you can observe with your eye, and you can also stick in the camera and do imaging with it. I'm a bit fussy with my imaging train. I found there was a little wobble, so I decided to do a fully threaded imaging train, which is the image on the left. And as you can see, it gets very long. So I prefer it that way because it's a little steadier, especially because you do have to do flat frames with solar, which is a tragic thing, but they really do help. Okay, so using this configuration, you can get really, really zoomed in on the sun. And I mean, you don't even know where you are here. You are staring at one sunspot. You're getting so much detail. You're seeing the umbra. You're seeing filaments. All those little bushy things are called spicules. And I mean, I just love being this zoomed in with the quark. But that being said, I do like zooming out with the reducer. And this was when I was doing some early experiments. So this is the exact same sunspot, but using a reducer. And you can see it's a little different, it's a little sharper, and it's a little easier to figure out where you are on the sun. You can actually see an edge. This is the kind of thing where if you don't have your little map of the sun, you won't even know what you're looking at, and you're not necessarily certain if you're, right side up or not. The other thing you can see really well in with the quark and NH alpha are spicules, and obviously what you're seeing along the edge are flary prominences, but the little tiny fringe, that's known as the spicules, and they're just little tiny little micro flares happening all the time on the sun. And you can get this level of detail with home equipment, which is insane. Of course, everybody loves the prominences and the flares, and that's the very dramatic part of imaging the sun. And this just happened to be a little flare I caught while I was in another part of the sun. I had to quickly zoom over to catch this little bright spot happening. And I do like to do time lapses. That's something I enjoy doing. This next image, of course, is what the chromosphere is really all about, which is that detail of sunspots. It's going to make you a little dizzy staring at this, but this was a time lapse where I just basically, I get my morning coffee, I sit out in the sun, I set up with taking some images, and I have an automated time lapse going for at least 2 hours. In about 2 hours, you can see movement on the sun. You can see activity between sunspots. You might even see little flares, little tiny explosions. The point of this was that one of the challenges with the quark is you are so zoomed in, it's very hard to get a full disk. You are always looking at little chunks of the sun. So I started trying mosaics of the sun. And with the quark, and even with a reducer, which gives me that wider field of view, it's a 12-part mosaic. And you have to really go fast when you do a 12-part mosaic of the sun, because it's changing. You don't want it to change by the time you image the layer below. So you got to zoom across 3 or 4 times and try to get all your images as quickly as you can. The one thing that has saved me is I've discovered that Photoshop has an auto align and auto blend feature, which has turned out to be really, really useful. And it made this mosaic, it put it together almost perfectly. So that is really great. So this is just a quick summary of sort of the process for solar imaging. I'm not going to go into the detail. It is pretty technical. I'm going to say that there are a few videos out there by Simon Tang. I think he's done 2 with Skywatcher, and I think he did 1 with Chuck's Astrophotography. And he starts from the beginning, acquisition, step by step, all the way along till he's finished processing. And he is well known. He's internationally famous. He's one of the best solar imagers out there. So his process is great. Just quickly, you need a monochrome planetary camera. You want a 3.0 camera because you want fast speeds. There are some really great ZWO ones, and the Player one, Apollo Max, I don't have, but I think if I was going to buy one, that would be the one I would start with. I do use SharpCap because of the Simon Tang videos. You don't need long videos. The sun is extremely bright. You do stacking and auto stacker, and you use the program IMPPG. It's a specialized program that you use for solar imaging. It'll do contrast and it'll do sharpening. And it's really the secret sauce behind a lot of wonderful solar images. To make your monochrome image color, make it orange, what you have to do is convert your image to RGB, and you just take your midpoint, your red, you raise your red levels, and you lower your blue levels, and suddenly everything is orange. So that's the trick for that. And I've already mentioned auto align and auto blend are like a miracle for me, and mosaics. And then this is just a pretty time lapse I did in June. Something that I didn't really realize until I started doing solar imaging is I can really only image from about March to November in my backyard in Ottawa. The sun just gets so low. I have no breaks in the trees. So in the summer, however, I do like to image primarily in the morning. It has the steadiest skies for me. I'm going to end up by just talking a bit about filaments. And that is that white thing you see moving around. These are solar storms up in the chromosphere of the sun. And again, this is an inverted image, so you're going to see that the sunspots are white. And this little bubbly area over here, it's actually an emerging sunspot region. It hasn't emerged yet. I was watching this filament because I was hoping it would erupt and fly off towards Earth, because that summer there was all kinds of filament eruptions. And again, as referenced before, they are very related to the aurora. So this, I'm going to pause it here. This is some imagery from the summer from SDO Observatory. So these are professional images. But I'd just like you to watch that big black filament in the top, and just watch it go poof, there it goes. That's just a great example about how these dark filaments can just fly off the sun because of all the magnetic activity that's happening these days. And this is from the LASCO coronagraph imagery, and you can see what happens when that takes off. I'm going to do it again. I'm going to pause. Oh, hang on. My mouth, there it was. I think you saw it. This really beautiful flamey thing came flying out. And this eruption wasn't aimed towards Earth. It went north. There is a part of the sun known as the Earth strike zone. And when the filament is launched from the Earth strike zone, it's coming to Earth, and it's going to cause us some aurora. The Earth strike zone is the western half of the sun. So if this one went to the north, but anything that launches in the western half of the sun, that's the Earth strike zone. Now I'm going to pause this again. This, I'm going to show you, this was an X-class flare that happened on New Year's Eve, and it's been one of our biggest X-class flares so far. And before we play it, you can see, look at that loop. You see that magnetic loop? That is the magnetic loop that we see, that diagram described earlier. Oh, I went the wrong way. Okay, let's play. Oh, I missed it. Hang on. Let me see if I can find it again. Oh, there it was. All right, so that's the X-class flare. This was an active region just coming around the east limb of the sun. It wasn't pointed at Earth at all. But when you actually look at what was launched from the sun on that day, and that was, you saw the big explosion going to the east. I'm just going to go back and forth a bit. You can see, in fact, the material went. You see how much that material is almost a full halo. So some material was also launched to the west. This ended up being a big solar storm that was launched towards Earth, but it didn't actually turn into an aurora. It kind of missed us, and it wasn't oriented the correct way. This slide came from another presentation that I did on how to, take a picture of the aurora. I'm just going to summarize by, if you do have the Space Weather Live app, you're going to get notifications for those flares. They're called, and the type 2 flares are the ones you want to watch. That means likely a coronal mass ejection has been launched. Step 2 is to find out, well, was it Earth directed? Because that matters. And there's a couple of ways of doing that. It's visiting the NOAA Space Weather dashboard. They have models. Following Space Weather Woman, Dr. Skov on YouTube. She does forecasts. She's amazing. And those 2 places should tell you, when's the storm arriving. It usually takes 2 days, 3 days, 4 days for a filament that's been launched to get to Earth. On the day you think it's coming, you need to then get out your Space Weather app again and watch for solar wind speed, solar wind density. Most importantly, the BZ, it's got to go south. If the BZ goes south, the atmospheric pressure goes up. And those 2 things make aurora. This is Dr. Tamitha Skov, Google Space Weather Woman. She has many courses. She does weekly forecasts. She's amazing. I highly recommend her information, her content. We talked about this. These were actually aurora images I took just up the road from here in Ottawa. So if you know when to go out and look, you will likely find something. And these are just some snapshots from that night. As you can see over here, it says BZ south, -13. That's really south. And I didn't take a screenshot of the hemispheric pressure, but it was at 96 gigawatts. So I knew something was happening. And it was even a full moon, and I could still see this aurora. And as soon as you have that kind of hemispheric pressure, you're going to see red in the aurora oval. Okay. So next, oh yes, I'm just going to end now. Obviously, the solar eclipse is coming. Everyone's excited. I'm so sorry, my phone is going. Yeah, hopefully you can't hear that. Hang on. Okay, sorry about that. Yeah, so these images were taken from Albuquerque. I ended up deciding to do an H-alpha telescope image because there was never going to be totality. For the eclipse this year, you're not going to use an H-alpha telescope. It makes no sense. As soon as there's totality, you won't see anything. So this was an annular eclipse thing as well. You'll see there's like little Bailey's beads. And when you see the next video, you'll see that there are actually some prominences in a good location. So I'm going to end with a time lapse that I took of the Albuquerque video. And there is usually dramatic music. And there we go. And those are all the sunspots from that day. And that is the end of my presentation. And I hope I've inspired you to try to take a picture of the sun. And I'm responsive to questions via emails or on Instagram. Thank you.
Thank you very much, Andrea. A wonderful presentation full of useful information for us and great images. So thanks again for presenting to the Toronto Centre.
My pleasure.
Do we have questions for Andrea in the room? Yes. Okay, let me walk over with the microphone.
Actually, I don't have a question. I just wanted to say that I'm your follower on Astrobin, and your images are very cool.
Oh, thank you so much.
All right, any questions in the room? Yes, we have one over here.
Thanks for a really cool talk. I was just wondering, where's the best place to get the solar film if we wanted to do some of the solar imaging ourselves here?
Yeah, apparently it's getting hard to find. The telescope stores that are in Toronto or just north of Toronto, Telescope Canada, Ontario Telescope, Kitchener Telescope. Well, you know what? Go anywhere. Go on Amazon. But you should try and start looking for it now. It can be hard to find. But I ordered all of mine. I got a whole roll of it from Telescope Canada.
Indeed. Any questions online? No questions. So over here, we have one in the room.
Thanks, Andrea. There was a discussion online as to whether during the 4 minutes or 3 whatever minutes of eclipse we can see, are there possibly going to be any changes in prominences? Because I suspect the images you showed were sped up rather quickly, and I'm just curious to know how fast they change. Like, do they change over 5 minutes or 5 hours?
They very rarely change more than in 4 minutes. I don't think they will change very much. That's one of the challenges of a lot of my time lapses is I'm staring at it for 2 hours and I actually don't see any change, but there's something subtle happening. I don't think there'll be enough time for anybody to capture movement. And that seems to be a sort of waste of your totality time. Like there are other things you could be doing rather than try and time lapse a prominence. So I don't think there'll be much movement in 3 minutes that we can see. That's my, I don't know.
I have a quick one for you, Andrea. Where will you be observing the eclipse from?
I'm going to be in my car heading towards Kingston, but willing to go east or west depending on the cloud cover. So I'm staying in Ontario.
Okay. Regarding Kingston, I was looking at the map and I saw that near Sandbanks is maybe the best place.
Definitely the Sandbanks area will be a good place. Mm-hmm. It is also really hard to get in and out of. So if you want to go there, get there early and plan on staying there a very long time. Okay. That is the feedback I've been getting from Kingston Rask is the getting in and out to anywhere close to the water. There's a lot of construction on bridges in the area. So just be prepared that, yeah, you might get in, but you may never get out.
I'm glad I asked. I wasn't aware of that.
Yeah, I would. I plan your routes around there easily. It's like only one road in to the park.
Right. Okay, we have a question in the room.
Andrea, this is Adrian. We were bunkmates over at Starfest.
That's right. That's right. Excellent.
I know both I and yourself, we chatted a little bit, but one of the things I didn't get to ask you while we're having Starfest time is what piqued your interest in getting you involved with solar imaging and imaging in general? Because I saw some of your images and they're amazing.
Well, the imaging I've always liked and I've always enjoyed. The solar imaging, actually, I'll tell you, there was a video, Dylan O'Donnell did a little video about the cheapest little easy way to take solar images, and it was with this telescope. And so I bought one, and it was so cute and cool. And as you know, a lot of people know, if you take pictures of deep sky objects, I mean, they're challenging and it's fun to find them, but they don't change. And I love that the sun is like always happening, and there's and you're always trying to catch that thing that might happen, or that flare or filament launch. So I think that's why I like solar.
We have, okay, one more question in the room, and then we'll move on.
So I'm a high school teacher with really limited funds, but this is really cool. What's the entry point for that cheapest thing? That thing you just showed me. How much might
This
that?
little thing, I think it was 1,000, maybe
Oh, that's cool.
1,000.
Cool.
Yeah, but what though you have to realize, because a lot of these scopes don't come with the little dovetail bar,
Yeah.
which adds money, and the little finder scope, it came with this. And there's a Lunt 50, which is a little cheaper, but I think this is better because it comes with the dovetail and it comes with the solar finder, which is important. It's hard to find the sun sometimes, believe it or not. But obviously this is the cheapest way in. It's just really hard to find this paper right now, the Bader paper. This is the cheapest of all, and you just need Bristol board.
Andrea, isn't the PST $500 or so, or am I behind the times now?
I don't know. I've never looked at the PST.
Yeah?
I don't even know. Do they still make them?
They still make them here. They're saying they still make them about $500, and
Yeah.
good job.
So I have a girlfriend of mine who has a PST, and she has had a lot of problems with imaging, trying to find the right back focus. She's had a bunch of issues with it. But yeah, that is cheaper. I like this one though.
Very good. Okay, and it's a Coronado PST, correct? Coronado.
Yeah,
Yes.
Coronado PST. That's the other option.
Okay. Let me go online here. 2 questions, and then there's another one in the room.
Hi, question here from Brian. How might the higher level of solar activity change the shape of the corona?
That I don't know the answer to. I do imagine we will have a lot more chance of really active prominences, for sure, because of the solar activity. How it would affect the corona, I hope it affects it and it's like more dramatic and exciting. I mean, that seems logical, but I'm not enough of a scientist to answer that question.
Understood. Okay, and Karsten wants to know, what are the recommended DSLR camera settings for a total solar eclipse? Is there a different setting prior to totality compared to totality?
All right, so there's really no way to practice these things. So what I have been doing is I've been going out with my DSLR and my mirrorless camera, and I'm practicing. First of all, you want to get your base exposure. So I know that with this camera, with my camera and this filter, and you want to be ISO 100. I think my aperture was, I think I had a little telescope, so my aperture was fixed. So I figured out you figure out your sharpest aperture for your lens, because it may not be, different apertures will be different. It'll probably be a mid aperture, f10 or something. And then from there, you find the exposure that doesn't overexpose the sun. That's your base. As the totality comes, you're going to have to keep increasing it. And in my experience, I just sit there. I click the whole time, and I'm bracketing on each side, and click, 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 and sometimes you need to increase, and sometimes you don't need to. And at some point, you'll get close to totality where you just want to do a range, and you want to have your sequence ready, because for the corona, obviously you want some short exposures and some long exposures, but you only have so many minutes. And the diamond ring, the big risk with the diamond ring is flare. So you want to try to get a few exposures around the diamond ring area. So just keep your ISO and your aperture fixed, but you're going to be moving your exposure, you're bracketing it as much as you can. It's digital camera, right? We can just click to our heart's content and worry about which one worked after. Right, that's my plan anyway.
Andrea, one more question in the room. Here it is.
Yeah, great. Thank you. That was very exciting. I'm eyeing that Lunt 40 telescope there. Can you recommend a website for constructing those solar filter caps for DSLRs? We made one of those at Starfest, but I feel like I've forgotten some of the steps and I have some of the leftover material.
Yeah, the one at Starfest, you know, was different because it was, you could flip it up for totality and flip it down.
Right.
So this one you'll have to take off and put back on. I only know of the Bader. This is Bader Astro Solar paper, and if you go to the Bader's website, actually I think I have it here somewhere. Yeah, www.astrosolar.com, and it'll tell you how to make this one. Find a Starfest person, and they can maybe tell you how to do that other one if they have the instructions. So I don't know. It looked like a neat idea. It looked very complicated though. But it's a good idea.
Yeah,
it's a good idea to be able to lift it up for totality and then put it back on.
If it's simpler, I'll be more likely to make one. Sorry, one more quick question. You know, when you see these pictures of the solar eclipse, you see sort of the total eclipse, but you see, I think, the flares coming out the side, and it looks really beautiful, like it's flowering almost. Is there anything special you have to do to take those kind of photos, or do you take that with the uncovered DSLR during totality? And that's how you get that image.
Yeah, those are taken without a filter during totality. The key you're going to want to make sure you're focused. So the best focus you have. I tape my focus down at the beginning of the eclipse. So you want to be in good focus, and you want to do a range of exposures during totality. And one of those will blow out your prominences, and one of them will be just perfect. You want a wide range. That's the advice I can give you on that.
Thanks again, Andrea, for presenting to us.
Okay, well, thank you so much for having me. I enjoyed it.
Good night. Have a good evening. Bye-bye. All right, we're going to go to fun facts for a moment while we set up the computer for our next presenter.
to it. Eclipses, and it seemed like something that I wanted to look into, and I'm lucky to have a group that will listen to what I found out because it's quite interesting to me. Didn't take long searching for this to hear about the total solar eclipse of Thales, and the reconstruction of the most likely eclipse is this one, if I can get the mouse working, and it goes from the Pacific off Central America. The greatest eclipse point is somewhere near Bermuda in the central Atlantic. And then it sunset would be somewhere around the edge of Europe, Turkey, whatever. Herodotus was born a century after this event. And it's sort of like me writing a story about the Fathers of Confederation gathering in 1864 and reading from local newspapers what happened. I mean, it's well past his time, but he did a lot of research and put things together. I've put all the words of the account, but it's rather wordy, so I'm just picking out the key things. There was a war between two cities that lasted over several years. And the quote is, "Just as the battle was growing warm, day was on a sudden changed into night." Now I remember one thunderstorm where the clouds were green, and I was terrified and herded my whole family into a small room downstairs where we'd be safe if a tornado hit us. And after a few minutes, the sounds disappeared, so we went up. And a few minutes later, we heard sirens of emergency people going to rescue people that were injured during the eclipse or during the tornado, which missed us. Anyway, after this event, because people those days thought that if something astronomical happened, it's probably caused by gods or whatever, and so they did make peace. Oh, wrong way. Pardon me. There. The account continues, this event had been foretold by Thales, who was from a third city, and he told somebody in a fourth city about it. And that sounds pretty impressive. But then it said, pressed the wrong button, pardon me, fixing for it the very year. Now, is that really a prediction of a total eclipse? And it reminded me of something that a very famous philosopher said when a punk pulled a switchblade on him, and Crocodile Dundee said, "That's not a knife," in his Australian accent. Well, to me, if you're predicting during the year, it's not a total eclipse, total solar eclipse prediction. To me, and I don't know of any official definition of this, but basically you need a date and a location of totality. Basically, what would be needed to eclipse chase? And I don't see that from there. Here's an example of one. That's the one we're about to come up in a couple of months. So it starts in the Pacific Ocean. The greatest eclipse is in Mexico, and it goes tantalizingly close to Toronto, but not quite good enough. And we all hope for good weather. I'm with a group that's planning to drive south, and we're hoping to find a place with good weather somewhere, but who knows? Now, a total eclipse is only visible on a tiny fraction of the Earth each time, and there's almost a 1 in 400 year return period to pick up an eclipse, although some places like Carbondale in southern Illinois is going to experience 2 within 7 years. Basically, no ancients predicted a total solar eclipse in terms of my definition. But they could very easily predict lunar eclipses that cover half the Earth, and they didn't do a bad job predicting partial solar eclipses. I want to go back to early religion. There were groups of people called priests, shamans, astrologers that explained to people that what happens in our lives are influenced by supernatural things, and often the supernatural things were astronomical objects. And can you imagine the incredible emotion when something happens to the moon or the sun? And I have an example of that. I read that a scientist flew down from, to Mexico, to the Yucatan, and she billeted for several weeks with a Mexican science teacher whose ancestry were Mayan. And what happened is the two ladies had wonderful conversations. It was just a magical time for both of them. But then a lunar eclipse came along. And I'm sure the science teacher copied the same diagram about eclipse shadows that I did, and probably most of you did in school. But she had rank terror on her face. And this shows that the whole concept of eclipses are a lot deeper for some people, and especially before science got good explanations. I'm going to wander a bit into the science of eclipses. The plane of the Earth's orbit around the solar system, sometimes called the ecliptic because that's where eclipses occur. The lunar orbit tilts about 5 degrees to that. And for part of the orbit, it is above the plane in terms of northern being up, which Crocodile Dundee would disagree with, and sometimes below. And the key is that we call this the ascending node, where it goes up, and descending. And that's when eclipses showed. So I put a little white dot there to represent the moon, although it would be dark in that situation. And on April 8th, 2 months and a day from today, there's going to be a magical solar eclipse. And it's going to be in front of the stars of Pisces. And if there happened to be a lunar eclipse on the same day, which of course there won't be, the lunar eclipse would be in front of Virgo. Where's the right button? Here. In 3 lunar cycles time, now the moon's orbit is pointing roughly the same way, but you see the moon is well above the plane of the of the Earth's orbit, and there are going to be no eclipses. But after another few, you get eclipse season again. And I wrote that there's going to be 1 lunar and 1 solar eclipse somewhere, and I found twice in the next century there ends up being no lunar eclipse. So I'm slightly wrong there, but I noticed that after it got in the slides. And of course, after 12 cycles, lunar cycles, you end up just a few days short of a year. And in some cultures, like in Babylon, they had a lunar eclipse, but the king could say, oh, we're getting out of cycle, and we'll just add an extra month. And some cultures do it, some don't. The problem is, if you want the month to tell farmers when to plant, you want something that goes on the solar system and the solar, schedule. Anyway, that's there. Now, if the moon were only affected by Earth's gravity, the sun's a long way away, it doesn't matter, right? Then every eclipse would be in Virgo or Pisces, because if a body is by itself in orbit, it just keeps going the same way. The only problem is that the sun also affects it, and for reasons I can't explain, it causes the line of nodes to bend backwards by 19 degrees a year. And I scaled this, so these are actual 19-degree bends, although that would be at the view from the top. And it turns out the eclipse season is every 5.8 new cycles, so sometimes it's 6 lunar cycles, sometimes 5. And this is part of complex patterns. Also, there's a perigee pattern that I'm not talking a lot about, but that affects whether it's total or annular. By the way, the perigee for our eclipse coming up in 2 months is the day before. So it's going to be close to closest, which is why we get 4 minutes of eclipse when we're in the right place. Anyway, there are all sorts of patterns, the way these cycles interact. And more than 1,000 years, Babylonians knew those patterns. It turns out the kings in Babylon, there was a belief that they must not be exposed to the light, the red light from a lunar eclipse. So there are all sorts of walkarounds. If there was a lunar eclipse coming, sometimes the king would hide and appoint somebody else to take his roles, and the person would say, what did I do to deserve this? Then after the eclipse, the king would take over and execute the guy, and just as before, he'd say, what did I do to deserve this? Anyway, because of that, the kings really wanted to know when eclipses were coming. So they funded the whole priests, astrologers, whatever you call them, that monitored things. And the Babylonian, I call them astrologers because the goal was not pure science. And they kept records on clay tablets like this one, cuneiform. And they had special events like eclipses and comets, but also details of the moon events, not just eclipses, but when the moon rose or set compared to the sun and different patterns. And I tried to find out if they measured the azimuth, because to me it would be very easy to have a specific place the observer stands. And when the sun sets, they have a set of degrees marked around it. And when the sun sets, that's one of the things they record about it, and the moon set. And that would tell a lot. And I tried to find out if that was part of it, but I couldn't. I'm still working on it. And Babylonians found that there was a repeat 18 years, 11 days, and 8 hours, roughly. And it's Edmund Halley that called it a Saros. It's more than just eclipses that have that pattern. The whole cycle of how the moon moves has that period, and is that cycle that was determined. Now, the modern explanation is that 223 new cycles is a certain number of days. A larger number of node cycles is almost the same. And a intermediate number of perigee cycles is almost the same. So when you have one Saros, you almost have every major property of the moon back to where it was. Not perfectly, but it's close. The Antikythera mechanism, that's found in a boat, and on it was printed 223. 223. So the people that made that knew of the Saros cycle, what we now call the Saros cycle, and it was part of it. I'm going to give you an example of total eclipses in the same cycle. I have a friend who went and watched this eclipse in 2006. It started in the Atlantic, just off Brazil, a little south of the equator. The greatest eclipse was in Libya. There are some people, I think, from this center that saw it in the desert of Libya. Did anybody here see the eclipse there? I think some Toronto Center members were, maybe not. A friend of mine was in Turkey, and he saw it. It was cloudy most of the time, but he had good luck on the actual moment, the only moment that matters. And then it went into the stands. Now, I just want to compare that to our eclipse in 2 months. Also starts a little below the equator, goes up. The greatest eclipse is at roughly the same latitude. And it goes on to, actually, people in Ireland will be able to see the partial eclipse at the end. But there's a difference. But look at the 8 hours. And the Earth spins counterclockwise like everything else, and it spins in 8 hours 1/3 of the trip around the Earth. And 1/3 goes from about Central Africa to Mexico. In 2024 or 2042, there's going to be another eclipse, 18 years, and it's going to be somewhere off. It goes through the Philippines, and it's mostly over water by China. Another 18 years, it's going to take it from there to almost a repeat of this one. The greatest eclipse point is still going to be in Libya. All right. And it's going to be almost the same. So when you have 3 Saros cycles, you get an almost repetition. And that's called an exoligmos. Not sure I'm pronouncing it correctly. And it turns out that many people think that that's the most important identifier or property of solar eclipses, much more than the Saros that gets all the publicity. Now, I just want to admit, when I was younger, I was really stupid. I was at university, and some friends came to me and said, "Do you want to join us driving down to Virginia and watch this eclipse?" And this stupid idiot said, "I have an assignment to finish." Anyway, they came back clear. They saw everything. They were just glowing. Anyway. I think another reason I didn't go is I didn't want to be part of a Carly Simon song about "You're So Vain" because she talked about somebody flew a Learjet near Nova Scotia. Anyway, that is an exoligmos from the eclipse that we're going to see. See, it's the same shape, a little bit wider. This eclipse is a little bit wider. The greatest eclipse point when the moon is new, when it's noon, is in Mexico again, and it's roughly the same shape. And if you predict that there's an eclipse on a date, there's a very good chance that 54 years and 33 days later, there's going to be another solar eclipse, but you can't tell exactly where totality is. And there's also going to be the same pattern for lunar eclipses. And I looked at the pattern of eclipses for this century, about 200 cycles of them. And there's so many examples where it's 54 years and 33 days and some not. But, no pattern is perfect. But in terms of ancients predicting eclipses, this pattern, once it was discovered, was very good at predicting lunar eclipses and partial solar eclipses, but totality, not so much, because totality is narrow, and there are a few places where you get totality in the same place twice, but usually it's either above or below, and there are complex patterns that make it. But if you had a country or an empire the size of Mexico, there's a good chance if you have one solar eclipse, total solar eclipse in your empire, there's a pretty good chance that 54 years later, you're going to have another one somewhere else in the empire. So that's to this stage, they found patterns. So good lunar eclipse predictor, not so for totality. Now we get to Greek astronomy. They used Babylonian records, and they worked on improving mathematical models. And you know what? There's a name for something where you take a whole bunch of observations and then you make mathematical analysis of it. And that's called science. And some people argue that astronomy was the very first science that was ever done. I can't tell for sure, but definitely these people were doing science, even though the purpose was to make sure kings don't get exposed to the light, the red light of a lunar eclipse. Hipparchus, a few years before in BC, was from Nicosia, and all his books are lost. It's sad, and for some reason, Europeans in the Dark Ages loved burning libraries. I don't quite understand it. But it could be the book will be recovered. And I just read an article yesterday in The Economist, although I'd heard about this before, that they found a technique where they can take a scroll in a library that was underneath the Vesuvius mountain and the hot gases spewed down and killed everybody but one guy in a prison. And it turns out that there are a whole bunch of documents that are fragile, but there's a process where they can fire X-rays or something at this and computerly analyze it, like what's it called, where they can work out the shape of something with multiple. Yeah. Anyway, that's it. And there's a technique that's being perfected, and it could be one of these scrolls, maybe this one, is going to be the book from Herodotus, not Herodotus, but Hipparchus, that's there. Incidentally, he's got a space mission named after him. The other major Greek guy is Ptolemy, and there are allegations that he kind of fudged a little data, and to my knowledge, there's nothing. There are no space missions named after him. But his book, Almagest, refers to books by Hipparchus, and it was the #1 book for astronomy for 1.5 millennia. Like, that was the authority, and what he said was obviously true, right? So, there are two assumptions in Greek models. By the way, the Mayans also believed that everything moved around the Earth. And you have the moon, and then you've got further circles. They also included Mercury, Jupiter, and Saturn, although that's not shown in this diagram. And these things move around the Earth, and there's a general cycle that everything rotates around the Earth every 24 hours. And there are other cycles on top of that to go the relative motion of these things. The second assumption was that everything moves in circles, and they all have uniform motion. So the sun moves evenly compared to the center of the movement. But there's a problem. It's easy to measure the solstice, the winter and summer solstice, by either measuring when the shadow is shortest at noon or when it sets furthest north or furthest south. The equinoxes are a little harder to measure, and there was reference to a bronze ring in Alexandria where it's completely flat and it's pointed where the perpendicular to the circle points to the North Celestial Pole. Then any star like the belt stars in Orion, when they shine down, a cockroach on this side couldn't see the stars of Orion because it would be blocked, or the stars of the belt of Orion, because they're on the celestial equator. And most specifically, there's a relatively nearby star. When it reaches equinox, it casts a shadow from this side to that side, and by carefully looking at the shadow, they could get the equinox time within a few hours, and they keep repeating it over many years, and they get accurate values. I tried to find out where this thing is, but on equinox, it would be interesting to see what happens to the shadow. And just at the last second, I found this thing from Beijing in China. And if this surface is perfectly flat and the other is perfectly flat, and the gnomon, the metal pointer for the sundial, were pointed exactly to the celestial pole, you would see funny patterns on the actual moment of equinox. Anyway, the season lengths are not the same. Summer's longest, winter's shortest, which is nice for us, but not so nice for Crocodile Dundee. So the solution is, well, maybe the sun makes a perfect circle in constant motion, but it's offset or a little eccentric from the Earth, and that you get the right balance. I mean, I showed it too far, but I'm just trying to show that you can make it that the number of days match. And I always assumed these were just pretty diagrams. But it turns out 60.8 days is 1/6 of a year. So in that time, the sun would move, compared to everything else, 60 degrees. Okay? But probably a high school student in trigonometry in grade 12 could probably figure out, if they knew that the Earth's fixed elevation is 15 degrees left or towards the winter solstice of the sun, and maybe it's 5% north of the overall, they could probably calculate that it's 57 degrees. And this is the sort of thing that the Greeks did, and they could make predictions. And those predictions were valuable because astrologers could say, in June 17th, Jupiter is going to close to Regulus in Leo, and that means kings have to be very careful not to start any battles then, or whatever astrologers predict. I like to think they often say, you know, you're going to make a tall, dark, and handsome guy or gal, and but you know, on this date. But anyway, I don't know about astrology. I'm not a big believer in it. For other things like the moon and the planets, they had circles upon circles upon circles, and that's called epicycles. And they made tables with predictions for navigators. And I'm going to show one example, also for astrologers. And every navigator would have, because there's all sorts of information that's useful for navigation, including Christopher Columbus. And he sailed the ocean blue in 1492, or whatever order it is. But this would be, 12 years after, and he sailed from Spain. Probably investors paid for the trip. He stopped in Santo Domingo, and he didn't get along with the governor. And maybe the governor was afraid Columbus would take some gold that the governor wanted to get. I have no idea what the problem was. Anyway, he wandered all over the place. And I've heard two versions. One is that there was a storm that broke his masts in the sailing. And another is that worms started to eat the wood of the boat, and he limped to Jamaica, and he went as far across the shore as he could, and he landed. And out of the bush walked some Arawak Indians. And they were willing to help. And according to a book written by Columbus's son, I don't know whether the son was on the trip or not, The sailors paid for food and they got food for a while. And I don't know, anyway, some people from the boat and some Indians paddled across to Santo Domingo to get rescued. I don't quite know how you can go through 200 kilometers of open ocean in a canoe and navigate, but they did, and they got there. And the governor said, "Nah, I'm not going to help them." And so it was a long wait. And eventually the Indians were less than happy to provide food for Columbus's crew. Where's my mouse? I've lost. Okay, there. Sorry. And Columbus was worried, but he noticed that there was in the tables a lunar eclipse coming up on February 29th. Now that's our system. They were using the old system, the Gregorian system then. So what he did is he called, and it looks like it was somewhere in the middle of the night that it was supposed to finally turn. So he called Indian leadership in, and they talked about a translator, but how they could communicate this. And he talked about how his God is very powerful and very angry that you Indians are not feeding my people. And he said, the God's going to take the moon away. And according to the book, the Indians were terrified, like the Mayan ancestry lady in, just a few years ago. They were terrified, and once it was total eclipse, Columbus went into, quote, a cabin. Now, I don't know if that was on the ship or whatever. And he had an hourglass, and he knew a predicted length of the eclipse, so he timed it. And eventually, he came back out, and he told the people that God is very angry at you, but he will forgive you if you feed us, and supposedly that happened. Now, I didn't mention the fact that the eclipse started at sunset rather than later on, but he was still able to pull it off according to the book. And as you can tell, the prediction wasn't that accurate, but I'm also highly skeptical that this even happened. That's the sort of story that sells books, right? And you'll notice that some stories include a particularly prurient comment that is to increase the sales. So I'm skeptical. The other reason I'm skeptical is I read some fine literature as a kid, and the comic book of King Solomon's Mines was lost or ripped up by my nephews. But I found an online source, and I bought this comic. And in this here, supposedly the hero white guys are about to be killed by a leader of some group or whatever. And they predict there's going to be an eclipse, and but we can take it away. And this guy, I don't know what his role was, but he said it will pass. I've seen it before. Well, you see an eclipse every 2.5 years of the moon, but you see an eclipse of the sun every 400 years. So it's unlikely he saw it before, but maybe he did. Anyway, the good guys or the white guys got rescued and whatever, but I'm just skeptical of the whole story. Then we come to a magical period of history in Europe. Copernicus was 20 when Columbus came back. He suggested that planets move around the sun, but he wouldn't let the book be published until he died. But he had it all ready to go, and when he died, it was published, and it was controversial. Later on, Galileo in 1609 said moons orbit Jupiter. He observed these dots that moved around, and he said they're moons. But the problem is, if everything revolves around the Earth, how can moons go around something else? Kepler, who's my scientific hero, and I'll explain more about him, he ditched the uniform circle idea. We aren't even, there are no circles in space. It's something else. And there was amazing art with Shakespeare, and these three lived for 45 years on this, they were alive for 45 years. And Copernicus was alive for almost 50 years, along with Michelangelo, the sculptor, and some guy that painted the Mona Lisa. What an amazing period of history. Anyway, Kepler was able to figure out that he was able to plot the orbit of Mars from about 20 years of data that he found out. And his first law says objects move in ellipses. And an ellipse can be made by cutting a cone, or If you make a circle inward and then you squish it, that's an ellipse. And that's the path of orbits. The second law is more important to me. And he figured out that if a planet sweeps an area in 30 days, then when it's closer to the sun, and that's why I made it such an elliptical ellipse, it's going to sweep the same area in the same time. And I think I made it a little bit big, but I'm losing my mouse here, but that's it. That allowed predictions of where objects are going to be in the future. Because if you know the parameters of the ellipses, you can predict where they're going to be, and you end up more accurate than Columbus found the prediction of the new moon, of the lunar eclipse. Newton, there's no evidence that Newton had an apple falling on his head, but two people wrote in their diaries that Newton talked to them that he saw an apple falling, and he figured it fell straight down. So whatever force caused the apple to moon came from the axe straight down. And he thought, oh, maybe that applies to the moon as well. And that's an amazing intellectual jump. Euler was one of many mathematicians that developed techniques to solve the three-body problem, because the moon's orbit depends on the Earth, the sun, and the moon, and they all interact in amazingly complicated ways. And until somebody developed those patterns and that mathematics, in my opinion, there were no clear eclipse predictions. Anyway, the first eclipse map was 1654 by Erhard Weigel, who was German. And he finished it the day before, but I think that's the map was finished. I think he knew where the greatest eclipse was, and I've made it red. Now, it seems like, well, how did he figure that out? Well, if you know exactly when the moon is going to be new, and again, you have to have accurate orbit calculations for that, that tells you the greatest eclipse point is going to be at the place where it's noon when it's the new moon. And the new moon is not a day on a calendar, but it's a specific moment in time. And he was able, from the time of the new moon, to figure out the east-west direction. Now, given that the Earth tilts sometimes with the seasons, it's not exactly longitude, but basically you could work out the east-west. Now, this eclipse, it's descending mode, so it's coming from north, and the new moon is before it crosses, then it crosses. That says that the actual latitude is going to be north of the equator. So the time between the new moon and the node gives a north-south direction, location. So they could actually calculate where the greatest point of the eclipse is, and that's when you are making a total solar eclipse prediction. And to me, it took that much. Who was the first eclipse chaser? I don't know. But I wondered, who would be the richest person in the world? I thought, well, maybe it's the King of Spain, Philip. Maybe when he was a kid, he had to copy the same solar eclipse diagrams that I did and the Mayan lady did, etc. And maybe also his tutor gave him some interesting discussions of what it was like to see a solar eclipse. Like, people blown away to see a solar eclipse. Most peasants don't have the language skills to describe it, but some people would have seen a total eclipse, would have described it, and maybe he said, I want to do that. So let's say he told his ambassadors, see if you can find a place where somebody's researching this. So they would go to different universities. Let's say somebody found Weigel and found out it's going to be there. So when the word gets back to Philip, he said to his military people, okay, Operation Eclipse Chasing begins, or whatever the Spanish term would be. So they would load a bunch of horses and horsemen into ships and wagons to pull the king, and tents and whatever is needed. And they would sail through the Mediterranean. I'm not quite sure you go upstream into the Bosphorus, but they must have had people towing them by rope, by oars. I don't know how that happened. But anyway, somehow got in there, landed on Crimea. They might have camped roughly where the charge of the Light Brigade is, because that's it. And guess what happened? This is the modern prediction of where that eclipse would have been. And the black dot is where he was, and I think he would have seen maybe Bailey's beads, but not the total eclipse. Still an eclipse prediction, in my opinion, but I don't think Philip would have seen it. But somebody must be the first eclipse chaser, and I tried to chase that down and I couldn't. This Eclipse Maps website, the only other one it lists is by Halley on 1715. And he predicted this and he published it well in advance using even more modern math. And he circulated it widely because to figure out where eclipses go, you need to have observations of the moon to work out when it's a new moon. But if he could find out, people said, well, you know, I live here and I didn't see totality, but this guy here lived and did see it, he would know whether it was north or south, and that would tell him more about the orbit of the moon. Anyway, he was about 30 kilometers off, and here's a drawing of the corona that somebody drew at Cambridge, and I'm not sure where Cambridge is, and I think it's a little north of London, is that correct? I don't know. Anyway, since then there have been lots of eclipses, chases, and I want to come down to the wonderful eclipse we're going to see 2 months tomorrow. I highly recommend the website eclipsewise.com. It's wonderful. Fred Espenak of NASA is part of it, and it has a path of the greatest eclipse in Mexico, and of course it swings up through Kingston, Montreal, and out to Newfoundland. Anyway, each of these white lines is 5 minutes. Now, I'm with a group from the Mississauga Center. I'm part of both. And we're planning to drive to somewhere near Indianapolis on the Friday night. The eclipse is Monday. Then to somewhere near Memphis on the Saturday night. Then we're ready to drive somewhere near Dallas on the Sunday night. The eclipse is Monday. And we have bookings for 2 nights near Dallas. And if it turns out we have to go even further south or not even go there because it's clear up there, we're totally flexible about weather. But the whole idea is we want to go to the best place to get it. Now, this website, you can zoom it in. And I haven't done a full zoom here, but you can actually zoom in to see individual streets of subdivisions. So it's an amazingly detailed map. When you click on a spot, like my nephew and his family and 2 kids live here, it gives you the exact time totality starts to the second, but I only copied to the minute. If you unfortunately are in Oakville and can't walk a couple of miles, a couple of kilometers, you only see a partial eclipse like King Philip probably did. And this also gives the time that it's largest. And it shows very specifically where it is. And I think my friend would say that is a total eclipse prediction. And this is 3,000 years of observation and math. Thank you. Anyway, I'd love to hear some questions. Paul, are you okay? Yeah. And I hope I can answer them. This is a really big field.
It's going to be a really easy question. So lunar eclipses seem to occur a lot more frequently than solar eclipses. Is that just because there are more places on the Earth where you can see the lunar eclipse, or is there something? Is it actually a different different number of eclipses anywhere on the Earth for each type?
I think it's about the same number of eclipses. You can have partial lunar eclipses, you can have total, and you can have, I think it's called an umbral, where part of the moon is covered by the darkest and not all of it. But I think every eclipse cycle, there's at least one, with a couple of exceptions for the lunar eclipse. In each cycle, it looks like there's always a solar eclipse. That seems to be what I do. But I think it's mostly the area we can see it.
Okay.
So
thanks.
2.5 years, you'll see a new lunar eclipse. It might be 4 o'clock in the morning when it's bitterly cold and windy, but there.
But if you were able to move anywhere around on the Earth, you could see it. How many? 12 times a year, or?
I'm sorry. What's that?
anywhere on the Earth, if does a lunar eclipse occur 12 times a year then?
Okay,
Or-
but a lunar eclipse could include a partial lunar eclipse.
Right.
And you have, according to the diagram, you've got your Earth here, you've got the umbra that is a complete shadow, but you've also got the penumbra that goes out, and you're going to have at least a penumbral eclipse every, with a couple of exceptions, every eclipse season. Okay? And similarly with solar eclipses, it could be that the moon just nudges a little bit, takes a tiny bite into the sun, but as soon as it does that, it's called, a solar eclipse. So the total is thing, but the number's roughly the same. But the key is that not every solar eclipse is a total solar eclipse. Like those are relatively rare.
Thank you.
Okay.
Okay.
Oh, good.
It was a really great. Wow, that was fascinating. Now I have this super cool opportunity so I teach at an Indigenous school in Toronto, and I have a really cool opportunity that I'm actually taking my students to Six Nations near Hamilton. We're going to observe the eclipse. The history of the eclipse for the Haudenosaunee people is that when they started their confederacy in 1138, there was a total solar eclipse that day. So they were able to predict when it happened. Also, I'm wondering, what's the phenomena you're calling where like the eclipse keeps coming back to a path or a very similar path?
Exligmos. I'm not sure how to pronounce it, but the Saros cycle is 18 years plus a third rotation of the Earth, and 3 of those is 54 years and an exligmos. I think that's how you say it.
Thank you.
No, thanks very much, and that's fascinating. I wasn't aware of that, and I'm giving this same talk twice more, and I might, if I could talk to you after and get specific details, and I might mention it in another talk.
Any more questions? Have anything online? How about the room? No, that's it. Okay.
Can I just ask a question? How many of you are planning to see the total eclipse? I'm just curious. You're going to drive somewhere. Okay, well, I wish you clear skies. The group of us, there are 10 of us, and we decided we were going to go wherever necessary, and hopefully I'll be in luck. And I have one photographic project, and that is I'm particularly intrigued by a phenomenon I haven't seen yet, and that's the shadow bands. And they're little wavy lights before and after the eclipse. So if you're watching the eclipse, look at the ground, preferably on a sheet, before and after the eclipse, because you see these little wavy things, and they're particularly intriguing. And I was in the camera shop looking at proper cameras to take a picture. Anyway, thank you very much, and all the best. Clear skies in the eclipse.
Thank you very much, Ron. As always, a very interesting presentation from you. Food for thought. So that concludes the speakers for this evening. Do we need to go to fun facts? Yes, we do. Okay, so we'll be right back for our online folks while we switch computers. And then our president, Tom, is going to deliver the announcements for this evening, and then we'll be done.
Adrian. Have and if you're coming to us from far, far outside the Toronto area, please let us know where you're joining us from. So our next speaker's night is on the 21st of February, 7:30 p.m., online only. Professor Andrew Hopkins, Professor of Astronomy from the School of Mathematical and Physical Sciences at Macquarie University in Australia, will be talking about the evolutionary map of the universe. So that's 7:30 p.m. online, live on YouTube. And then on the 6th of March is our next Recreational Astronomy night, either in person here at the Science Center or join us live online. Arnold Brody will be discussing the sky this month. Arushi Nath will be talking about integrating sparse and dense photometry methods for improved asteroid property analysis. And Michael Watson will be talking about how to photograph eclipses, solar and lunar. Solar observing here at the Science Center, next up on Saturday, March the 2nd from 10 a.m. to 12 p.m. So just outside the door here, RASC volunteers will be setting up properly filtered telescopes, and you can take a look at some of the sunspots and prominences and other features that you heard about in tonight's talk. Weather depending, of course, and please check our website in case it's for a go or no-go call. City Star parties for members only. Our Bayview Village events are on hold for the winter. The Long Branch Park pilot project is ongoing, but it's on an ad hoc basis. Basically, if it's a Friday, Saturday, Sunday, or holiday night, and it looks clear, take a look on the website for a go, no-go. This is the sort of thing that the call will be made shortly beforehand. That will not be scheduled. Coming up at the David Dunlop Observatory on Friday, the 16th of February from 7 to 9 p.m. in person, June Parsons will be talking about the James Webb Space Telescope and the search for life in unexpected places. The registration fee is as listed, and to register online, the links can be found at rascto.ca. And then on Sunday, the 25th of February from 12:30 to 1 p.m. is virtual Sunday sun gazing. The registration fee is listed, and again, the links are at rascto.ca. This is the first winter that the CAO is open all winter long because we've got the road plowed. Naturally, the snowfall is a little less than normal, but c'est la vie. Things are largely back to normal, but there are a couple of exceptions. The biggest one being that for folks staying overnight, it's a maximum of 2 unrelated persons per bedroom. You mutually agree to share that bedroom with masking in common areas only. It's encouraged, but preferences for those who are in attendance will be taken. Public outreach events did resume over the fall and the summer and fall, and will re-resume in the summer. Please see the online CAO bookings page for details, and please read everything before making your booking. We're still looking to fill a few spots on our job board. We're looking primarily for a volunteer committee chair, somebody to coordinate all the people who want to volunteer to help with the events of the Toronto Centre. We're looking for a marketing committee chair and committee members, and we're always looking for additional help with the education and public outreach committee, especially online presenters and telescope camera operators for virtual star parties. A reminder to anyone who'd like to volunteer, you first must be a member of the Toronto Centre. Drop me a line at president@rascto.ca. This is where I plug the joys of RASC membership. If you like what you've seen tonight and want to be a part of us, please, you can sign up or renew online at secure.rask.ca, and gift memberships are available. Contact the national office at mempub@rask.ca. Also, I'd like to invite everyone here in the audience to join me at the meeting after the meeting at the Granite Brew Pub, 245 Eglinton Avenue East. That's the southeast corner of Eglinton and Mount Pleasant. There's free underground parking. We are usually in the front room. The only downside is we have sort of gone late this evening, so the odds are unfortunately pretty good that by the time we get there, the kitchen will be closed. So the bar only will be still open. For everyone else, thank you very much for joining us and have a pleasant evening. Please follow us on all the forms of social media we've got listed here. If you've been watching us live on YouTube and you like what you see, please click the notification bell. Please subscribe. Be safe and keep looking up. Good night, everyone.